Hello everyone, welcome to the online video tutorial series of computer network subject. In this video, I will explain distance vector routing algorithm. In previous video of routing algorithm, we already discussed the algorithm. Now, in this video, I briefly explain how the distance vector routing algorithm is working. So let's start with outline. So we learn first what are the basics of a routing process, what are the types of routing, and distance vector algorithm in detail. So when we are talking about the routing process, so routing is all about selecting the path along with the network and data packets traffic. So our goal of routing is to send the data to the destination with minimal efforts that achieves the simplicity, correctness, robustness, stability, fairness and optimality of our routing. So for that purpose, computer network is introducing different types of routing algorithm. That routing algorithms are divided into the different categories. For example, it can be dynamic or static. It might be distributed or centralized. It may be intra-domain or inter-domain. It might be single path or multi-path, or it can be flat or hierarchical, or we can say that it will be link state or distance vector. Now, how the exactly routing is performed? So when we are talking about the routing process, each and every router is connected with the next network. That network having some identification. That identification is done by your network address, and that is maintained by your router. So any IP destination is containing specific IP address. When it receives by the router, it first identify the packet headers. That headers having the information of the next router where the particular data item is belonging to. For that particular router is implemented by the different routing algorithms. So routing is all about how the exactly packet is moving from our source to destination. For that routing algorithm is implemented. But when we are talking about the particular router, how the data is moving from one router to another router, for that it maintains the forwarding tables. So we can say that mainly two things are there: routing algorithms that determines end-to-end path for the particular packets, and second is forwarding table that determines the local forwarding from one router to another router. So this is the basic idea how can we calculate the data processing of packet from one router to another router and from source to destination. Now we are moving to the routing table information. If any router is maintaining any table, then how can it will maintain it? So for that, it contains the destination address. What are these particular field destination address that is received by the particular data packets? What are the belonging destination address and next hop address? If my destination is my next hop address, then it is same. But my destination is not directly reached by the particular hop, then next hop will be the particular next hop address. For that, we are using this type of graphically data maintenance. So here we can see that A, B, C, D, E, F, G different nodes are there, and nodes are connected with links, and some cost will be there. If I want to reach A to B, I need some cost. If I want to reach A to C, I have two options. I can reach A to C directly, or I can go A, B, C. So this is the also alternative. So from the cost effectiveness, we will calculate how the particular data item is reached to our destination with minimum cost. But for all routing, we have to maintain the particular routing table. Now we are moving about this particular directly graph. So already discussed this particular data items are available here, that A, B, C, D, that are identified in the round, that will be identified as a router. The line will be known as a link, and the one is considered as a cost. So this is a very simple graph how the particular graph identification of source to destination of our routing table. From this we will take the best cost. That best cost will give us the optimal solution to reach our data packets from source to destination. This methodology is known as a direct graph methodology that is maintained by our router. Now, we are moving to link state algorithm. In detail, we learn link state algorithm. So, when we are talking about link state algorithm, it is an iterative asynchronous form. So when we are talking about link state, it will identify the cost from the node to all the other nodes one by one in the iterative manner. After updating its value, it shares with its neighbor. If neighbor is comparing to reaching that particular different nodes, both the values are same, then it is not updated. If the destination value is lesser than updates, if it is larger than not updated. So after updating the routing tables of the each and every node, it will share to the another nodes. This process is iteratively ended till each and every node is not getting optimal cost to reaching from that node to all other nodes. So this is the very basic concept of link state algorithm, that is the iterative and is asynchronous. Now, if we see that in the iterative manner, then for each and every node it waits for change in the local link cost. If any node is finding the cost change, then it will send to its neighbor only. Neighbor is recomputed with the help of the change value, and if the distance of any destination is changed, then it will notify to other one. So this is a simple scenario how it will be working. Now understand this terminology with the help of this example. So let's move here. Our total data items are A, B, C, D and E. Here bidirectionally data can be moved here, each and every node having some cost. For that we are considering this routing table. So here we are considering value from each node to another node. So let's move to our initial state table. So in the first row we are moving to the destination to node, and the first column we are putting all our available routers. So A, B, C, D, E is considered as an information of node, and from this node how the cost is available, that is our first row value. Suppose from A, consider the first row here, first row. From A, I want to move A. From A to A, there is no cost available, so 0 will be there. Now next, from A to B, I can reach directly with the cost of 7, so value will be 7. Now A to C here, we cannot reach directly, because if I want to move from A to C, I take route A, B, C, or A, E, B, C, or A, E, D, C. So there are number of options, but from A to A we cannot reach directly. That's why here distance will be known as a infinite here. The same way we can say that we cannot reach A to D directly, so the value of that is infinite right now. But we can reach A to E directly here, so the value is here 1. That's why we are putting that value 1. So I think all of you very clear about how the first row is written here. So from first row, A to A 0, A to B 7, A to C infinite, A to D infinite, and A to E 1. The same way we can write for node B. From node B, I can reach directly how many nodes? A, C, and E. So you can see that from B to A, we can reach Y 7 value, yes. B to E, we can reach Y 8 value, yes. And from B to E, we can reach Y 1 value. From B to B is 0, but from B, we cannot reach directly to D. That's why the value is written here infinite. So the same way we can write for say node C, node D and node E. So this is the basic initial state. So for basic initial state we have to take care only one thing. From the particular node, how can I reach the other nodes? If I reach directly, then we have to use value. If I can't reach directly, then value is infinite. So it is the basic thing. Now we are moving to how the data is updated. If the value is infinite, now what is the next step? How I can reach that particular node? So understand that D is sending vector to E. So we can say that for our particular D node, neighbors are C and E here. So we are taking here first scenario. D is sending its forwarding table with updation to E. So here we can say that from E cannot reach directly anywhere. Okay, from E I cannot reach C directly. Okay, so what are the updation are here? Okay, for E here we can say that in the previous from E we cannot reach C here. This is the initial state. Okay, we are also writing that from E I cannot reach C directly. But when D is sending forwarding table to E, then it will update its table. So what is the updated table? Let's see here. From D we can reach to C via two values. E is knowing that already E to D value is 2. That's why in the last row you can see that E can be updated the value to reach C via 4 value. How the 4 is calculated here? In the E table, previous table, E is knowing that we can reach to the particular destination D by 2 value. That is the consider in the last row here. E to D value will be 2 here. And from this particular D value, it will calculate. From D, C will be 2. This is highlighted portion. We can see that from D, we can reach via 2 value. So that's why it is updated that value with this particular condition. So D is 2 away. That's why 2 plus 2 is 4 and it is less than infinite, then particular E is maintaining this value. So this is the condition here. If the condition is that if our next calculated value of neighbor is lesser than the current value of node, then we can consider. But if it is greater, we cannot maintain them. But in this case, this condition is satisfied, then E is update its data table. Now, let's take another example. B is sending that data vector to A here. Okay, now from A, we cannot reach directly C here. But here we can say that B is sending this particular value to A here. So what happens? From B we can reach to C by 1 value. That is the case here. But A knows that A can reach to the B via how many value? 7 value. So it will check here from B is 7 away and B to C is 1 value here. 1 plus 7 is 8 here. Yes. And it is less than infinite? Yes. That's why A is updating its data value to infinite to 8 here. So now, according to this table, A can be reached to C via 8 data values. So this is another case how this particular value is frequently updated. Now, let's take another example. E is sending the vector to A here. Okay. Now we can already know that from A directly it cannot be reached to C. But just before we can already know that A is updated the data value. A can reach to the C by 80 value. Now when E share the data to A, what happened? Let's calculate. So already in the previous slide we can see that A to C is 8 data value, 7 plus 8, because already we share this table form. Now E is sharing the data value to here. Now let's see how the data value is updated. So E is telling that From E we can reach to C via 4 value, and from E we can reach to the D via 2 value. So here it is updated because A to E, A to D is here infinite because it is not directly equal. So our E to D destination is 2 and A to E destination is 1 here. So we will check 1 plus 2. 3 is less than infinite. Yes, that's why E is updating its data table. The same way it is updated to reach the C data value, because we know that from E it can be updated here by data value 5. Okay, so this is a basic scenario. How can we update each and every data table? 5 is coming from here. A to E is 1, E to D is 2, and D to C is 2. So that's why our data value is updated. 1 plus 2 plus 2 is 5, and that is lesser than 8 here. So in previously we can say that 8 is lesser than 4, so that's why it is 19 in the data value. So this process is iteratively moving again and again till that each and every device of your network is not getting optimal solution, or we can say the minimum cost, okay, to reach one node to another node. So this is the basic idea how our data item is moving using the cost, and how the exactly particular distance vector is calculating internally. For that we are taking this particular example. For B, if B wants to move all other nodes, then how it internally calculates the value. So from B, if I want to move A, from A, then my value is 7. That is the first case. From B, if I want to move E, then my value will be here 9 here. That will be telling here. From particular data item B, if I want to move C, then that value will be here 6 here. So from that we will take the minimum one from where we can reach the particular value. The same way it is calculated for all these destinations. From B, I want to go via A, via E, via C. So if we have a number of alternatives, then which will be better one? So via C is the better one here. 1, 2, 2. Okay, that's still another value is 8, another value is 7. So we are taking the minimum one here. That is our case. So this is the basic idea how the link state algorithm is working. Thank you for watching this video. In next video, we will discuss briefly another algorithm.